Hi, we are going to have a quick look at what do we mean by non-linear derivatives. Now, one of the good examples to speak about this is a call option. So here you can see I've drawn the payoffs of a call option with respect to its underlying. So let's assume this is a call option on a particular stock. So we know that as the stock price keeps increasing, the value of the option will increase, and that's the reason we can see it's an upward sloping curve. The change in the underlying, in this case it's a stock option, so the change in the stock to the change in the option payoff, it's not linear. In other words, the slope of this curve at this point, let's assume at this point, the slope of this curve at this point will be different from the slope of the curve at this particular point and also at this particular point. So in other words, the slope keeps changing as you move along the curve. Now this is different compared to linear derivatives. Now when we spoke about linear derivatives, if you remember, you can see whether the S&P 500 index moves by just, let's assume, just by a small amount here, or whether the S&P 500 moves by a larger proportion, or you're somewhere here and it moves by the same amount, the change in the futures price to the change in the S&P 500 is always a constant. If you remember, we said the constant is, in this case, is just $250, because the value of the futures price is simply the index value of the index multiplied by a constant. So for a linear derivative, remember when we talk about linear derivatives or nonlinear derivatives, it's always with relation to a particular risk factor. In this case, for a index future, the risk factor is the index. So for a linear derivative, the change in the value of the derivative compared to the change in the underlying will always be a constant. Now for nonlinear derivatives, basically if you see here, let's assume the stock moved by $5. It just increased by $5. You can see when the stock increases by $5, you can see the option price slightly increased. Now let's assume that we are somewhere here, so the stock is quite high, the stock value is quite high. Again, the stock increased by $5. Now here you can see, even though the stock increased by the same amount as here, the option value, the change in the option value is not the same. Here it was quite small compared to here, it has increased quite a lot compared to this move here. In other words, what we are saying is the slope of the curve, because if you look at this curve, the slope of this curve at this point and at this point is not the same. So let me just show it to you. So here the slope of this curve is, so let's assume the slope of the curve is something like this. Now you can see the slope of this curve here and the slope of this curve here is quite different. It's not the same slope. You can see the slope is quite different. Let's assume at this point, you can see the slopes are quite different. And because the slopes are quite different, the change in the option value will be different. In other words, it's not proportional to the change in the underlying. So these are called nonlinear derivatives. And we'll discuss this in another video. The change in a options value compared to the change in the underlying is called the delta of an option. In other words, what we are saying is, for a nonlinear derivative, the delta, in this case for a call option, the delta of the option keeps changing as the value of the underlying changes. Now for a linear derivative, the delta is constant, because you can see it's just the same slope. It's a straight line. Whether you're here or you're here or you're here doesn't matter. It's the same slope. Now why this is important is because when we calculate the VAR, or the value at risk, of linear derivatives and nonlinear derivatives, we cannot use the same model, especially if we are using simplified models to calculate value at risk. The same model will not work. Now, if we use some other models, they'll suit much more to calculate all the derivatives, linear and non-linear derivatives, but more simplified models will not work for non-linear derivatives, and we will discuss that in another video. So remember, when we talk about non-linear derivatives, what we are saying is that the relationship between a particular risk factor and the derivative is not linear. In other words, the slope keeps changing. Now, there are some derivatives, if the maturity of the derivative is quite short, it will behave like a linear derivative. But if the maturity of the derivative is quite long, then it behaves like a non-linear derivative for certain risk factors. So we cannot just say, for example, an fx forward will always behave like as a non-linear derivative. That's not true. An fx forward with a shorter maturity will behave as a linear derivative with respect to the spot price, but an fx forward with a longer maturity will not behave like a linear derivative. So it's quite important when you talk about linear and nonlinear relationships, you need to understand the derivatives and how each risk factor can affect the value of a derivative. So this is an introduction, so I hope you understood the concept. If you have any questions, you can put it on the comment section or just drop us an email. And if you like this video, you can click like and also subscribe to our channel, and I'll post more similar videos. Thank you.